Hello, good morning, everybody. So, first of all, welcome to all of you to the source of information and also in the new video of the previous year problem solution of Icfre chemistry questions. So, in the first video, we have to discuss about the 1 to 25 previous year question, and in that video, we have to discuss the rest of the 25, that means 26 to 50 questions, and in that manner I have uploaded all the videos up to 100 questions of the previous year which have been taken in the 2020. Okay, so before I am not wasting any time, so I'm just going to the question 26. The CH bond distance is longest in. The CH bond distance is longest in first one acetylene C2H2, second one C2H4, ethylene C2H6, ethane, and C2H2Br2. Okay, C2H2Br2. So in all the cases, we already know that when increasing the bond multiplicity, the bond distance decreases. So triple bond has the bond multiplicity 3 and it has the shortest bond distance. Shortest is the triple bond and is the double bond is somehow larger and is the single bond. So acetylene means it's a triple bond multiplicity. In that case, it's also bond multiplicity 2. It is also bond multiplicity 2. So only the option C, ethane, is the bond multiplicity 1. So that's why it has the longest bond distance. Next one is 27. The predict the product of the following reaction when acid is react with hydrazoic acid HN3 in acidic medium. It's a Smith reagent. Okay, it's a Smith reagent. What happened in that case? The C double is group and one isocyanate intermediate is formed, and this intermediate is hydrolysis by water to form the amine, primary amine. This C double H group is changed into NH2. That means it's a step down reaction. One of the carbon atom has to change into NH2. So 1, 2, 3, 4, 5 carbon atoms there. So generally we have to get only 4 carbon atoms. So option A is the correct answer. This is not the correct. In that case, the C5 one carbon atom increases. Okay. Next one, when organic compound was treated with sodium nitrite and HCl in the ice cold condition, nitrogen gas was evolved. The compound is. So by observing the condition sodium nitrite HCl ice cold condition, that means 0 to 5 degree temperature, it's a name reaction of Sandmeyer reaction, and the Sandmeyer reaction the nitrogen gas is only evolved only for primary amine, and the primary amine only react with this Sandmeyer reagent to evolve the nitrogen gas. कार्बन इन कार्बन डाइऑक्साइड इज. सो कार्बन डाइऑक्साइड का कार्बन कौन सा हाइब्रिडाइजेशन में है ये जानने के लिए हमको इसका स्ट्रक्चर जानना पड़ेगा. सो कार्बन डाइऑक्साइड इज जस्ट ए लीनियर स्ट्रक्चर. कार्बन डाइऑक्साइड जस्ट ए लीनियर स्ट्रक्चर and if we already know that from the Vespa theory, a linear structure, the carbon has the 180 degree bond angle, that means it's a sp hybridized. Okay. Next one is C14 has the half-life of 5760 years. 100 milligram of sample containing C14 is reduced to 25 milligram in how many times? So and it's a radioactive decay reaction. Radioactive decay, it's a first order reaction. For first order, we have know that T equal to 2.303 by K and log A0 by AT. So log A0 means initial concentration. So starting with the initial 100 milligram, so under denominator 100 and down 25 numerator. And K, what is the value of K? K is the rate constant. For calculating the rate constant, what we have to done, K equals to, we already know the formula, 0.693 by T half, and here the value of T half is there 5670. So we have already calculated the K, and by putting the value of K we can calculate the value of T. So by putting all the numerical value, we get the answer 11520 years. Which of the following has the minimum gold number? So gold number, it's a problem or questions from surface chemistry. So minimum gold number has the gelatin. The value of the gold number is 0.015. 0.015. 0.5 to 0.0125. to 0.0125. So gelatin has the minimum gold number. Okay, and also if you know the other gold numbers, starch has the gold number 20 to 25, and gum arabic has the gold number 0.1 to 0.15, and sodium oxalate has the gold number 5 to 10. So gelatin has the minimum gold number. And the next one is the electron affinity of the noble gas. The noble gas, we already know that it is a very inert element. It neither donate or accept any electrons. That's why its electron affinity is 0. Ozonolysis of toluene gives. So ozonolysis of toluene, first we know that how ozone can break the double bond. It is the structure of toluene. Toluene is one benzene ring with the head one methyl group. Okay, so if we ozonolysis this compound, it can only break this double bond, and to break this double bond, and one carbonyl group has to be added to each of the carbon atom. Okay, so for that, after hydrolysis or ozonolysis, we have to get the glyoxal CHO and CHO, 2 moles of glyoxal, and with that we have to get also 1 moles of methyl glyoxal, MECHO, and in downside CHO. Okay, so option, which one is right answer? 2 moles of glyoxal and 1 moles of methyl glyoxal, option C. Then what happened? Then the limiting radius ratio of ionic solids follow the order. So limiting radius ratio, the largest for body center, उसके बाद square planar, and after tetrahedral, and then planar triangle. Okay, Clemenson reduction will convert cyclohexanone into Clemenson reduction. The reagent we have to use zinc amalgam HCl. It can reduce the carbonyl carbon to methylene carbon. So cyclohexanone means the benzene ring with one carbonyl group in the top of the side. It can reduce the Clemenson reduction to give this type of compound is called cyclohexane. So cyclohexane, this is the option C. The first ionization potential of sodium, magnesium, silicon, aluminium are in the order. So ionization potential value increases from left to right when you move from sodium to magnesium and then aluminium and then silicon. So ionization potential value simply increases left to right. Okay, so silicon has the highest ionization potential value. So option B, D and E are correct. Option C is not the correct. But there is some correction, is that first ionization potential means the amount of energy required to remove the first electron from its valence shell. And if the valence shell are half filled or full filled, then the ionization potential value increases somehow, as you have to expect it. So if you observe the electron configuration of magnesium, its valence shell configuration has 3s2. So 3s2 means the s orbital has the full filled electron. So since the s orbital has the full filled 2 electrons, so it has required some amount of high energy to remove the electron from its valence shell as compared to the aluminium. So option B should be the correct answer. Silicon highest and lowest sodium, but magnesium should be highest as compared to aluminium and sodium. Okay, so out of copper, zinc, Ag and iron, the metal which can displace all other from their salt solution, copper, zinc, iron and Ag, which can displace the all other salt solution. Potassium, so for that we have to know the reactivity series of the metal that we have to read on the class 10 or 9. Okay, so it's a very basic concept. So so in that case I have to write down the reactivity series one by one. So which one is more reactive? Potassium should be the high reactive, and then sodium, after sodium the calcium, उसके बाद मैग्नीशियम, पोटासियम, सोडियम, कैल्शियम, मैग्नीशियम, एंड उसके बाद एल्यूमिनियम, उसके बाद कार्बन, आफ्टर दैट जिंक, आफ्टर जिंक द आयरन reactivity, and after iron the tin, Sn, tin means Sn. Uske baad lead, lead means Pb, and after Pb the hydrogen has to become hydrogen, then copper, then Ag, okay, and gold, Ag, Au, and platinum. This is the reactivity series, and on down the group the reactivity decreases, and which is on top of the group is the high reactive metals. Okay, so among the four options we have to observe the zinc is on the top of the series among these four. So zinc should displace all the form of the salt solutions, so high reactivity zinc. In the electrolysis of dilute H2O4 using platinum electrode, so when we have to electrolysis the H2O4, the hydrogen gas is liberated at the cathode, because hydrogen is H plus ions is formed and cation moves to cathode, so hydrogen is liberated at the cathode, and oxygen gas is liberated at the anode. Oxygen is liberated at the anode. So only on one option which can match the criteria, hydrogen is liberated at the cathode. Oxygen कैथोड में नहीं होगा, ये एनोड में होगा. हाइड्रोजन इज लिबरेटेड एनोड, ये एनोड में नहीं होगा, ये कैथोड में होगा. और Cl2 का तो कोई बात ही नहीं, तो ऑप्शन ए इज द करेक्ट आंसर. The impurities present in the rainwater process is dash charge. So first of all, this question is wrong. The approach of this question is wrong. There is no impurity, also impurity is present, but there is no charge. But if anybody, he or she has to attend this problem, he has to get the full marks. If you attend or non-attend or not attempt, you have to get the full marks. Which of the following is called the calomel electrode? Calomel electrode are the two options, AgCl2 and KCl. Ag2Cl2. So here the one options you have to write down that Ag2Cl2, which is also known as calomel electrode, and also KCl is also one type of calomel electrode. Okay. Acidic or basic hydrolysis of geminal dihalide or the type of these would generate. So if we hydrolysis acidic or basic of the geminal dihalide, say for example this, so what happened when this can undergo the acidic and basic hydrolysis, it can form the geminal diol, one carbon atom OH and R dot after downside OH. Okay, geminal diol. So geminal diol is very unstable compound. It can easily liberate the water molecule to form the ketone. Okay, to form the ketone, water molecule has to be liberated easily in acidic or basic condition. So the correct option is ketone. Which species does not exist? Among the four options, the ligand should be same, fluoride ion, and we can vary the central metal atom. So metal boron in one case, aluminium, indium, and gallium. And among the metal, we have to see that both of are in the group 13 element, and on down moving down the group, we know that the size increases. Boron should be the less size, small size. So because of small size, it cannot accommodate the 6 fluoride ion around itself. That's why the BF6 does not exist. BF6 3-. And OSO4, osmium tetroxide, is a reagent used for obviously hydroxylation and also cis hydroxylation of alkenes. Okay, syn hydroxylation of alkenes. If we do the trans hydroxylation or anti dihydroxylation, in that case we have to use the MCPBA reagent. Which salt gives the crimson red color frame? It's a salting test. Crimson red give the strontium chloride, and calcium give brick red, and sodium gives grit yellow. So our correct option is SrCl2. The correct order of having ability from saturated carbon atom of the following living group. So living tendency, which one is the more? So living tendency is more for osmium OTS. OTS is a very highly living group, because after living it can generate a stable compound, that's why, which can undergo resonate. OTS, paratoluene sulfonyl chloride. So after leaving the O minus, this O minus can resonance here, and also the sulfur vacant d orbital is there, that's why it can stable. The OTS would be the highest living group. So OTS, and OH minus the least living group. So only one option is there in which the OTS should be the most prior. So option B is the correct one. The maximum magnetic moment shown by ion, which is the electronic configuration of this. So maximum magnetic moment. So magnetic moment formula mu equal to root over of n into n plus 2. Where n means number of unpaired electron. So by following the equation, we have easily understand that increasing the value of n, the mu value increases. That means the magnetic moment increases. So we have to calculate the in which case the number of unpaired electron is highest. So for 3d8, the number of unpaired electron 3, and for 3d5 the number of unpaired electron 5, and for 3d4 the number of unpaired electron 4, and for 3d9 the number of electron unpaired electron 1. So the 5 should be the highest number of unpaired electron. So n value increases, the mu value also increases. So this is the highest maximum magnetic moment value of the electronic configuration 3d5. Detergent action of soap is due to alkalinity, solubility of water, emulsifying property, ability to produce leather with water. This is the correct answer. Emulsifying property. The boiling point of glycerol is more than the propanol, because so for that we have to know the structure, because the structure of glycerol is CH2OH, and after the CH2OH it says CHOH, and in the downside CH2OH. This is the structure of glycerol, and propanol has the structure of CH3 CH2OH. Okay, so boiling point depends on the number of hydrogen bonding. With increasing the hydrogen bonding, the intermolecular force of attraction increases, so more amount of energy or heat has to be required to break this type of bond. So as a result the boiling point increases. So in propanol there is one hydrogen bonding, but in glycerol, because of due to the presence of 3 alcoholic OH group, 3 types of hydrogen bonding, 3 hydrogen bonding has to be formed. So which can increases the boiling point? So major reason is hydrogen bonding, not hybridization, not arrangement of molecule, not all of these. So only hydrogen bonding in the major cases. The number of double bonds present in 10 alunins, and anulins, 10 anulins has the structure of like this, just like naphthalene. Naphthalene has the bond, it's a fuse system, but in that case we have not used the C9 and C10 bond. This is the anulin, 10 anulin, because all the structure, the 10 carbon atoms are there. If you count 1 2 3 4 5 6 7 8 9 10 with the double, single, double arrangement of the double bond. So this is the 10 anulin, and the number of double bond is total 1 2 3 4 5. So 5 is the correct answer. And last one is a salt producing hydrocarbon among this compound. Salt producing hydrocarbon. So ethane, methane, ethane and ethene. And the salt producing hydrocarbon, the hydrocarbon which one is more acidic, that can easily liberate the hydrogen and can produce the salt with reacting with the base. So among the ethane or ethine, the ethine is the more acidic because it contains the sp hybridized carbon atom, which is more electronegative, and that's why it can easily release the H plus ions to form the salt like this. If we react with sodium NaOH, then it can form a CHC triple bond C minus and here Na plus. Okay, this is the salt has to be from. So ethine the correct answer. So that's all for that day. If we have discussed the problems up to 50, in the next video I have discussed the problems up to 75 and then up to 100. In that manner we have completed all the series. Okay, till then, goodbye, see you.